So, trig of a point. What we're talking about here, and there's very good possibility you're going to see something like this on the ACT. It's super easy. What they're going to give you is they're going to say something like the point 34 lies on the terminal side of an angle. And they're going to ask you different things for sine of that angle, cosine of that angle. Most of the time they won't ask you for the angle, but I'm going to go a step further and show you how to actually find the angle today. But if the point 34, again, go over 3, go up 4, we'll just kind of sketch a little graph of it. The point 34 lies on the terminal side of some angle. Before we begin, can somebody tell me if that angle is bigger than 45 or smaller than 45? It looks right at 45, doesn't it? And I drew it like that so you wouldn't know. Think about it like this. A 45-degree angle has a slope of 1, correct? If you have a point, that would be like 3, 3, 4, 4, 5, 5, 6, 6. If you want to get technical about it, y equals x would be the actual line. Has a slope of 1, has a y-intercept of 0. That would be any 45-degree angle. So the point 3, 3, 4, 4, 5, 5, 6, 6 are all on that 45-degree slant. So the point 34, instead of 3, 3, it'd be a little bit higher. So this should be an angle bigger than 45 degrees. It should be around a 50 or 60 degree angle. But what they're going to say is, they're going to give you a point that's on the terminal side of an angle. So here's my angle. We've rotated up. You've got the point 34 that the terminal side cuts through. And they're going to say something like, if the point 34 lies on the terminal side, then what is the sine of that angle? They're not going to say find the angle most of the time, but they will say something like find the sine of that angle. Super easy. Watch this. Draw yourself a reference angle. Okay, actually draw the triangle. And here's, again, your reference angle. To get to this point, here's all you have to do. To get to this point, you went over 3 and you went up 4. Guys, that's the two sides of that triangle. Your x value would be 3, your y value would be 4. That's how you got to that point. So if they ask for what is the sine of this angle from yesterday, remember, or day before, SOHCAHTOA. The sine of an angle is opposite over hypotenuse. And the first day we didn't cover this, I don't think, good enough. But make sure you go back and know your Pythagorean triples, 3, 4, 5, and 5, 12, 13. If you don't remember any of the other ones, please remember those too. So if you have here the point 3, 4, then we already know by the Pythagorean theorem or by Pythagorean triple, the hypotenuse is 5. There's so many applications that we're going to get to later when we deal with vectors that applies the same material. We're going to get into applications that involve imaginary complex numbers again and trig form of complex numbers. That'll be next year. All of this will be. That involves this exact application. So you have the point 3, 4 lies on the terminal side. And we know the distance from 0, 0 to that point, because Pythagorean theorem would be 5. So in order to find the sine of this angle, you simply do opposite over hypotenuse, which is 4/5. Like I said, there's several of those on the ACT that's all they'll ask you to do. So they'll give you a point. They'll say find sine, cosine, tangent, cosecant, secant, cotangent. They'll say find one of them. Just use your little right triangle that you drew. Okay. The biggest mistake that people make sure that you use your reference angle, that you draw the triangle down to the x-axis and not over this direction. Okay, let's go a step further though. They didn't ask you to find the angle, but I want you to know enough about trig that to see that all this stuff is related, see that it's all connected. If you have this, then you have the angle. Because from that first day when we were solving triangles, if I needed to find the angle, if I needed to get theta by itself, all I did was move sine over. So if for some reason on the ACT they say what is theta, they're not going to give it as a degree measure unless it's one of those special angles that we just took a test on. They're going to say sine of theta equals 4/5, so therefore theta must be the inverse sine. Remember how to move sine over, the inverse sine of 4/5. That's how they would leave their answer. But I want you to take the one extra step. Plug that in, somebody, for me, and tell me what the sine of theta is actually equal to. So the sine of theta is 53.13. We'll just call it about 53 degrees. which should make sense. 3, 3, that would be a 45, 45, 90 right triangle. Does everybody understand? If this was 3 and this was 3, that'd be isosceles. The angles would be the same, making it 45, 45, 90, but it's a little bit bigger than 45. It's about a 53-degree angle. Here again, let's say that negative 6, 7 lies on the terminal side of an angle. That angle would be in the second quadrant. Negative 6, up 7. You don't have to be exact, just sketch you out a little drawing. If this is the point negative 6, 7, that means that you went left 6 and you went up 7. Draw yourself a little reference triangle. And notice what I did here. I put my angle here. This process, I made everything positive as well. The process that I'm about to do, the way I work it, is going to give you an acute angle. It's going to give you this angle if you're looking for that angle. Okay, if you're looking for the angle. But be careful when they give you this one, and I'll show you why in just a second. Okay, let's say that we're looking for, let's do secant. We haven't done a lot with secant, cosecant, and cotangent, so let's find the secant here. And in order to find secant, secant is the reciprocal of cosine. So in order to find secant, let's actually find cosine first, and then we'll flip it. And now we have secant. So again, looking for cosine to begin with, we need, here's my angle. That's my reference angle, is where you always put your angle. Adjacent over hypotenuse, we have no idea what the hypotenuse is. A squared plus b squared equals c squared. You're going to get really good at Pythagorean theorem over the next couple of years. 36 and 49, I think that's 85. So c would be root 85. 85 is c squared. To get rid of the square root, so the square root of 85. You can try to simplify it. 17 times 5 gives you 85, and there's no other way to break that down, so this is just root 85. Cosine, again, is adjacent over hypotenuse, which would be 6 over root 85. But you've got to be careful of something. I take away my negatives. I don't even worry about the negatives because I know that all students take calculus, and I know what's positive and what's negative and where it's positive and negative. Since we're dealing with the second quadrant, cosine is an x value. Cosine is how far left or right this point is. Does everybody understand that since we're in the second quadrant, that needs to be negative? And you could, if you would have left that negative 6 there, you would have got that. The distance here is always positive, but negative 6 over root 85, you would have got the same answer. But just make sure that, again, that you always check, if you're in the second quadrant, is it supposed to be positive, is it supposed to be negative, and so on and so forth. So everything's positive here, sine is positive here, tangent's positive here, cosine's positive here. All students take calculus. That does not factor in secant, cosecant, and cotangent. Okay? If we know sine, cosine, tangent, then you're going to see here in just a second, this is going to take care of itself. Now that we have cosine, in order to get secant, simply flip it. Root 85 over 6, and it is still negative. That negative you can put on top, bottom, or out front, it doesn't matter. Let me share one other thing with you. Here, if I would have rationalized that, if I wouldn't have thought ahead and I would have rationalized this here and multiplied top and bottom by root 85, I would have got negative 6 root 85 over 85, and then I would have turned right around and flipped it, and that would have put the root 85 back on bottom. Don't do that. If you're about to flip it anyway, just leave it on bottom, and that way when you flip it, it's back on top. It does not, again, it's not going to ask you to, but let's go a step further, and I'm just curious what that angle is, because I want to help you with something here. I go back, when I'm looking for angles, I just think this is a good habit. Go back to where you started, and let's look at this little triangle. And you can use sine, cosine, tangent, whatever to find this angle. If I need, for some reason, an angle, if they give you a point, share that with me. If they give you a point, and you're looking for the angle of that point, the terminal side, actually makes, you'll always use what trig function? The y value will always be the opposite. You see that? the x value will always be the adjacent. So if you're given a point, in order to find the angle, you'll always use tan. Will you not? Because the point will be the opposite and adjacent side. The x will be adjacent, the y will be opposite. So that way you don't even have to use Pythagorean theorem if you're just looking for the angle. The tan of my angle is equal to opposite over adjacent. Solve it for me, please. Now, I could have got the same answer from here, but I want to show you. Inverse tan, somebody tell me what theta is. 39? 49? So theta is about 49 degrees, but do you see why I'm cautioning you? This is not a 49-degree angle. The way I solve it, I don't worry about positives and negatives and all that. The way I solve it, this is your reference angle. This is not the actual angle. Here, if you remember, an angle in standard position starts here at 0 and rotates from there. The way that I solved it with the opposite over adjacent gave me this angle right here. This little triangle, so this is 49 degrees. So can somebody tell me what this would be? 131, right? Subtract it from 180. So if you're at the point -6, 7, the terminal side that passes through that -6, 7 will have an angle of 131 degrees. Is there any questions? Let's just do 3 -6, and let's say that I'm just wanting the angle. I don't care, you're not finding sine, cosine, or tangent, I just want an angle. So here's how you'd find that angle. Plot the point, make sure you know what quadrant it's in. Over 3, down 6, it's somewhere down here. It doesn't matter as long as you're in the right quadrant. Draw yourself a right triangle and label, again, what I do is I label the reference angle. This was 3, this was 6. I'm not concerned with positives and negatives because what I'm going to do is I'm going to draw this little reference angle and I'm going to find this angle. And I can use this reference angle, and again, reminder, the reference angle is the angle formed with the x-axis. I can use this reference angle to actually find out what this angle is. Very easy. Again, from the last problem, like I told you, you'll always use tangent if you're given a point because it's opposite over adjacent. The tangent of my angle is 6 over 3. That's 2. Move the tan over. Somebody do inverse tan of 2 for me, please. And, round it to the nearest degree. So about 63 degrees. Everybody understand how he found that? Just inverse tan of 2. So this angle right here is 63 degrees. But I want to know what this angle is. Okay, the angle from here around to there. All the way around would be 360, but I didn't go all the way around. I'm 63 degrees short, so that would be a 297 degree angle. So the angle formed by the line that passes through 3 -6, that terminal side of that angle would make a 297 degree angle.